We're going to be starting lesson 13.2, which talks about exponential decay functions. So kind of related to lesson 13.1. 13.1 talked about exponential growth functions, and this is just the opposite. So we're talking about decay functions. Let me kind of just explain the difference between an exponential growth and exponential decay, and that depends on the b term of the exponential function. So exponential decay occurs when the base, so when b, is between 0 and 1. Remember that any number that's between 0 and 1 is a fraction, and then that's what we see in these equations. An example of an exponential decay function is this one. So f of x equals 1/2 to the x power. Another one is f of x is equal to the 1/10 to the x power. Now I do want to note that just because something is a fraction, it does not mean that it's a number between 0 and 1. And that example is here. So let's say that you have a function that is f of x is equal to 5/2. Well, even though this is a fraction, this is actually a improper fraction where the numerator is greater than the denominator. And actually, if we were to simplify 5/2, that is a number that is greater than 1, 2.5. So this example here is an exponential growth, not decay. Remember that decay occurs only when the number where b is between 0 and 1. Okay, so then what we're going to be doing is we're going to be looking just how we did with exponential growth functions. We're going to be comparing parent functions and transform functions. Then let's go to page 20. At the bottom of page 20, so I kind of have my notes on the supplemental note. So let's say we have a parent function, and the example that they give us is f of x is equal to 1/2 to the x power. And then we have a transform function, which is g of x is equal to the 1/2 x minus 6 plus 2. What we need to identify are a, h, and k. So in this problem, a is 5, h is positive 6, and k is positive 2. Using the same rules that we learned about transformations in lesson 13.1, if a is greater than 1, that's called a vertical stretch. If h is a positive, so this is h is positive 6, that means that we're translating 6 units to the right. And if k is positive 2, that means we are translating 2 units up. So I will be okay with just these statements of how the transform function is different than the parent function. But I just want to show you another way of responding with a sentence, and that's what they have in the packet. The transformations that have been performed on g of x are a vertical stretch by a factor of 5, translate 6 units to the right, and translate 2 units up. So this is just a way of summing up all of this information. So the a, h, and k wrapped up into one sentence. Okay, so now let's look at one more example. Okay, so in this example, the parent function is f of x is equal to 1/5 to the x power. And remember, this 1/5 in the parentheses is the base, so that's a b. So we expect that b to be the same in the transform function. This doesn't really change. What does change is that a could be added, h could be added, and k could be added. In this problem, we have g of x equals 1/4 times 1/5 to the x power minus 7. A is a fraction. A is 1/4, and K is -7. So kind of looking at the rules, what happens when A is a fourth? So when A is between 0 and 1, that is considered a vertical compression. When K is a negative, so K is -7, we're translating 7 units down. So let's look at the statement that they wrote for this problem. The transformations that have been performed on g of x are a vertical compression by a factor of a fourth and translate 7 units down. So as long as you guys are able to let me know what is occurring on the test, you're going to have options of what is also occurring. So so do not worry if you are having trouble writing a sentence like this. I'm fine with identifying. I think the main important part is identify A, H, and K, and then write the rules that go with whatever A, H, and K are. So let's practice 2 problems before we move on to the next lesson. And this is a good point. This is a good part to pause the video. So I really want you guys to try these problems on your own and see if you get the correct answer. So again, pause the video and then play it to view the answers. But this right here is my parent function. F of x is equal to 1/3 to the x power. This here is my transform function. G of x equals 3 times 1/3 to the x plus 2 power. So let's identify what we have. We have a. So what I'm going to do is I'm going to write a is equal to +3. We have an h. H is equal to -2. And then we have a k. K is equal to -4. So what happens if A is greater than 1? So that is called a vertical stretch. When H is -2, that's translate 2 units to the left. And then what happens when K is -4? That's a translate 4 units down. So these are our 3 things. There's a vertical stretch of a factor of 3. There's a translate 2 units to the left and translate 4 units down. So next, for problem number 2, this is my parent function. F of x equals 1/5 to the x power. And this is my transform function. G of x equals 1/5 to the x plus 1 minus 1.5. So let's kind of go through these statements, and what we're trying to find out is which one is true. So the first statement is g of x is compressed by a factor of 1/5. Now I do see that there is a 1/5, and what determines a compression is if A is 1/5, but this 1/5 belongs to the B. So this is incorrect. G of x is translated up 1.5 units. So when something gets translated up, that's what K is. And if it's going up, K has to be positive 1.5. If we look at this function, K is actually negative 1.5. So this is incorrect. Next, g of x is translated to the left 1 unit. And what translates something to the left is h, and if we look at h, h is actually -1, because remember, to get an x plus 1 here, it comes from an x minus a -1. And h is -1, and this is correct. Okay. So the next part of this lesson is looking at reference points of exponential decay functions. And given a transformed graph, how do we find the transform function? How can we create an equation given a graph? So I'm kind of using this table, but I'm going to kind of walk you through some of the steps to this. So this is a parent function. So f of x equals b to the x power. The first reference point is 0, 1. Second reference point is -1, comma 1 over b. And then for the parent function, the asymptote is y equals 0. Now let's translate that, and this is the translation equation, or I'm sorry, the transformation equation. So then our first reference point is h, comma a plus k. And then our second reference point is h minus 1, comma a over b plus k. And then the vertical asymptote is y equals k. So let's look at the example 2 on page 22. And what we're going to be doing is we're going to be looking at the graph that they give us. So this is the asymptote. This is my first reference point. And this is my second reference point. So let's start with the asymptote. So in this equation, or in this graph, y is equal to 4. That's the horizontal asymptote. And then in the formula, so k is the asymptote, so y is equal to k. So in this problem, k is equal to 4. So we got that here. My first reference point is -3, 1. And if I compare that to my first reference point here, h, comma a plus k, h is -3. H equals -3. And then a plus k is equal to +1. So a plus k equals +1. And then we're going to plug in 4 for k to find a. If you subtract 4 to both sides, we get a equals -3. So therefore, we have all of our values for our letters. A is equal to -3, b is equal to 1/2, h is equal to -3, and k is equal to 4. And then to put all of this together, we have our equation right here. G of x is equal to -3, so that's what a was, to the 1/2, that's b, to the x plus 3. So remember, h was -3, so negative negative makes positive. And then k is +4, so we have that +4. Okay, so then let's try a problem. So again, I would pause the video and try this problem on your own. The first thing you want to do is find out what k is, then find out what h is, and then find out what a is. So my asymptote is y equals negative 3. So what that tells me is that k is equal to negative 3. Next, my first reference point so actually, let's look at the first reference point on the previous problem. Okay, so my first reference point is 0, negative 2. So let me write that point, 0, comma, negative 2. And again, what that means is that this is h, comma, a plus k. So h is equal to 0. And then we could find out what a is by setting a plus k equal to negative 2. So a plus k equals negative 2. And if k is negative 3, and if we add 3 to both sides, we get a is equal to 1. So we have k, h, a, and then b was 1 over 5. Now, putting all of this together into one equation, what I'm going to do first is I'm just going to plug in everything into the equation, and then I'm going to simplify the equation. So g of x is equal to 1 times 1 over 5 to the x minus 0 minus 3. So then we don't really need this one here, and then x minus 0 is just x. So this becomes g of x is equal to 1 over 5 to the x power minus 3. And that will be your solution for the transform function. Okay, next, let's look at the graph for number 2. So now we have to choose A, B, or C, which equation goes with the graph. And then again, we want to start with K. So in this example, K is equal to 1 because the horizontal asymptote is y equals 1. So K equals 1. Now, if k is positive 1, we could actually rule out b because they're telling us k is negative 1. So we know that's not an answer. So then what we need to find out is what is A and H. So let's look at our first reference point. Our first reference point would be 1, 0. So let me write that point 1, comma 0. And we're going to compare that to h, comma a plus k. So h is equal to 1. So I'm going to write h equals 1. And then if we look at these two equations, both of these have h equal to 1. So I guess the only thing that we need to find out is a going to be positive 1 or a going to be negative 3? So let's set a plus k equal to 0. And let's plug in 1 for k. And let's solve for a. A would equal negative 1. So the correct answer would have to be C. F of x equals negative 1 over 3 to the x minus 1 plus 1. Okay. Okay, and then the last part of this lesson is modeling with exponential decay functions. And I kind of want to just look at the equation for modeling exponential decay functions, and that is this equation. So A of t is equal to p times 1 minus r to the t power, and p is the initial value, r is the rate or the percent, and t stands for the time. Now what's different between this equation and then the equation that was in the modeling exponential growth functions is this sign right here. So for decay, we're subtracting r to 1. For the growth, we were adding r. So let's look at an example. Let me read a problem. The value of a truck purchased new for $28,500 decreases by 9.5% each year. After how many years will the truck be worth $5,000? Graph the function on a graphing calculator or at desmos.com and use the graph to make the prediction. So what we're going to be doing is we're going to be looking at the initial value of the truck and then the rate. So initial value is 28,500 and the rate is 9.5%, which changing this to a decimal becomes 0.095. Plugging in those values into our equation, we have A of t is equal to 28,500 times 1 minus 0.095 to the t power. 1 minus 0.095 is 0.905. And this is our function that we're going to graph on Desmos. But then we're also going to be graphing this function, A of t equals 5,000. And then we're going to be looking for the point of intersection. So I know we have the solution already, but I just want to show you guys how to type this on Desmos to get your answer. So let me switch screens. And my first function is A of t is equal to 28,500 times times 0.905, and then we're gonna click on this button to put the exponent to the t power. And then the second one is A of t is equal to 5,000. And don't worry if you don't see nothing here. We need to zoom out to find out or to see where the graph is occurring. Okay, so then let me zoom into where these cross, and let me just center this. Okay. So this intersection is 17, 5,000. So it will roughly take 17 years for the value of the truck to decay to $5,000. Okay, now so around 17.4 years. Okay, now let's try, or I want you guys to try one problem on your own. Now, I want you guys to just be careful with this formula. This is the same thing as this formula. This formula right here. A is the same thing as P in these problems. I actually would prefer you guys use this formula to do this example here. So on federal income tax returns, self-employed people can depreciate the value of business equipment. Suppose a computer valued at $2,765 depreciates at a rate of 30% per year. Use a graphing calculator to determine the years it will take for the computer's value to be $300 or $350. So I'm going to make a note that this is P and this is R. P is equal to 2,765. R is equal to 30%. And then 30% as a decimal is 0.3. So your equation would be A of t is equal to 2,765 times 1 minus 0.3 to the t power. And that is A of t equals 2,765 to the 0.7 to the t power. So this is the first equation that you're going to graph on decimals. And then the second equation that you're going to graph is A of t equals 350. And again, we're looking for the point of intersection because what we're trying to find out is how much time is it going to take. So what is t equal to? So let me again switch to decimals. Let me clear out these equations. Our first one is A of t is equal to 2,765 times 0.7 and then to the t power. And then our second equation is A of t is equal to 350. And let's zoom out and find out where the intersection is occurring. So it seems like it's occurring here. Okay, and if we click on the intersection point, it will take roughly 5.795 years for the value to return to 350. So 5.7. Now 5.795, we could actually round to the nearest tenth, and that would actually be 5.8 years. Okay, class, so that wraps up this lesson, lesson 13.2, which talked about exponential decay functions. So again, try the homework on your own. List the transformations that occur on the first three problems. Write the transformation equation based off the reference points and the asymptotes. And then on the checkpoint, or actually we had some more problems in the back. And then on the checkpoint, we have two problems here. All right, thank you. $26. So let's write that. T is equal to 19.926, or roughly 20 years. Okay, so, and that answers our question. It will take 20 years for a value of a baseball card that originally is worth $3.25 to be worth $26. So that completes lesson 13.1. If you do not have a Algebra 2 Credit 1 packet, and you do not have a printer to print out the homework or checkpoints, then I would just suggest you write the question on a separate sheet of paper and then show your work for each problem and then submit that on Google Classroom. You do not need to draw any graphs for problem number 3 or 4. You just need to write the exponential function. And then use decimals for problem 6 and 7, and then you have the 13.1 checkpoint on page 18. Okay, have a good day, guys.